A little background, Piranha is a company out of Switzerland, and we have partnered with them to be the North American distributor for their self-centering zero-point vices, as well as their coolant line. And most of you know about lock line, the plastic stainless steel type coolant lines. Most of you are familiar with the blue and the orange coolant line. And the reason that we have the Piranha coolant line is because it is a anodized aluminum, and the manufacturer of the vice line was using the plastic coolant line, and noticed that when he's running lights out, he'd come in the next morning and the coolant line would be busted in half, or it would be knocked out of the way, and coolant was getting all over the machine and basically ruined cutting tools and ruined some parts. So he decided to make his own coolant line. So with some trial and error, he came out with some anodized aluminum coolant line, which gets up to about 1100 psi, 80 bars, if you will. Lock line's up to about 120 psi, so it shows you the biggest difference. And what that really means in layman's terms is that on a vertical or horizontal or a lathe, you can get a lot more pressure out of this. You don't have to dial your coolant pump down to use the plastic line. You can now use the aluminum and get the full pressure that it was designed to use to get it through the cut zone, to do the chip evacuation, help keep your cutting tools cool. We have three different sizes of coolant line. This, what I'm holding you right here, is a 1/4 inch. We have a smaller size, which is the 1/8 inch, and then we also have a 1/2 inch size, and that's the ID. I call it sort of an erector set because you can take the parts on and off. You just unscrew them. They have a little Vitron ring, you'll notice, if you can see the little rubber seal on it. It doesn't have anything to do with keeping the coolant in the coolant line. This has to do with putting pressure on the joints. So as you're tightening this up, you can get it as tight as you want it so that you can actually move it into your machine. And so as you're machining throughout the day or the night, you're not going to get any movement once you got this tightened down into your machine. One of the other features that we have is we have a variety of nozzles. If you notice on this one, this is a multi-port nozzle. There's 7 1.5 millimeter nozzles in here, as opposed to this nozzle, which is just an open hole design, which is similar to what the lock lines are. And the issue you have with these kind of nozzles is you're going to get some turbulence of the coolant inside the back end of this nozzle. So the coolant just kind of spews out. I kind of refer to it like your garden hose. If you take the tip off your garden hose and put it at full bore, it just sort of blows out the end of your hose. Once you put your nozzle on and you go to that multi-port nozzle on your garden hose, you can notice the higher pressure, the more direct line that the coolant's going to be getting into your cut zone. And one thing I wanted to show you basically is we've got some installed right here on this machine. Wheel it around here so you can see. This is the Piranha here with the lock line in the back. You can kind of see how the lock line is not a very strong stream, but you can see the difference in the streams once I put the Piranha on versus the lock line. And see how easy it is to adjust. It's also very sturdy, and you can hit it with your hand when you go in to change out a tool, and you're going to have to reset it again. Where here you can hit this one quite a bit, and it's not even moving. You can see the stream's not even hardly moving, but you can get it so that it's hitting the cutting tool. So that's the vertical machine. Some of the biggest advantage on the verticals especially is going to be your chip evacuation, getting the chips off the cutting tool itself, getting them off the machine if you've got the coolant lines that are actually doing the cleaning of the machines. So you're going to be able to clean the chips out of around the vices or whatever work holding you've got, versus the lock line. Like I said, with the lock line, you're sort of getting the kind of the open hose effect, as you will. And one of the other items that we have on the Piranha coolant line, we also deal with grinders. And with grinders, we have nozzles that come in different sizes so that you can get them up against the grinding wheel, and because of the flow that's very strong, you can get it a little bit farther away from your grinding wheel, so you're not going to get enough of the buildup on the front of these nozzles. One thing I will tell you with the nozzles that have the multi-ports on them, it is very critical if you're out into a customer is to find out what kind of filtration system they're using on the machines. We've got some people on here now that have some very quite a bit of experience where these will clog very easily if they're not actually running the coolant through good filtration. So, and if that's the case, they keep having issues with it getting clogged, then you have to go back to one of the open hole designs. But as long as they can keep their coolant clean, using the multi-port is always the way we start out when we try to get somebody to use our coolant line. And with the grinding, I just showed you the tooling heads for the grinding. Now we'll go over to our lathes, which is another area. As you can see, when you go into a customer, we've got the mills you can look at, we've got grinders, and now we're going to flip around here and take a look at the lathes. Oh. You can see, hopefully you guys can see the turret. Most of this is not uncommon with lathes, obviously. They've got the turret. You don't need a hold, go ahead. On the turrets, you're going to have these little brass balls. You'll see a lot of these brass balls on our turret lathe right here. And these brass balls basically have just one little opening at the end, and they're hollow. And they get put into the female hole here on this lathe. Basically, they go into a hole like that. The downside to these brass, number one, they're brass, so it's very soft, so it's very easy to get this crushed or to deform the hole. And it's also an open hole design, so I'm going to show you in just a second what it looks like with this brass ball. So what we do with the brass balls, we take it out. And we have another one, which is a multi-port, which comes with the same ball size as what I just took out. You'll notice the two ball sizes. It's hard to see this camera here. And this goes in the same way as the brass ball does. It also gets put into the turret like that. There is a ring, though, that goes over top of it, like that. And actually, it's this ring that gets clamped into the turret so it doesn't damage the ball. So you're not going to get the ball bent like you do with the brass ball. Now I'm going to turn it on here real quick so you can see the difference. So I don't know if you can see the difference with between the brass ball and our lathe ball itself. But you're getting a lot higher degree of pressure right through the cut zone versus what comes with the turret itself. I can't really hear you guys, but if somebody could text me or chat over here if you could see it okay. Okay. I'm going to shut the door and go ahead and turn it off.
That's pretty awesome, Scott.
Well, that's just the little lathe ball we got. You'll notice up on top, well, maybe you don't notice. Now you will. I don't know if you can see this very good or not, but there's a copper tube in the back. Oh. Can you see the copper tubing? Well, the copper tubing is very standard. You go to any shop that has a lathe, you're going to see the copper tubing. And basically what you're doing is it's nothing but a hollow piece of copper, and they have to get it to their cut zone. So they're bending it. And as soon as you bend that copper tubing, you've kinked it. So now you're getting zero pressure for the most part off the copper tubing. Well, we have a solution for that as well. Basically, it's that same ball that I just showed you, but there's a thread on the end. Get it unscrewed here for you. And this is what this adapter looks like. It has the same ball as the little lathe ball does, but as you notice, it's got a female or male thread at the tip, and from that, this goes into the machine like that, and now you can plumb off of that thread to take the place of the copper line. And so now you can bend this around. This also comes with, you could use the multi-port, or you could use the other open hole design if you wish.
That thread allows you to use every component in our quarter-inch system.
Correct, yeah. As Dan mentioned, this thread I just showed you on this ball, it's the 1/4 inch thread. And so all the other components out of the coolant line will fit onto this 1/4 inch thread. We also have some adapters for our 1/8 inch system and also for our 1/2 inch system as well. These coolant line items you can get a la carte, or you can get starter. They do come in starter kits as well. All three sizes come in their own starter kits, which has a wide variety of items. I would say, and Dan could chime in also, the best way really we found to do this is to actually have to get out in front of the customer, go to their machine, quickly put in the items that they're having issues with, or you want to show them and do the demo and get your sales that way. Because if you just take a demo kit in, show them the pieces, how they go together, it's really cool, yeah, that's nice. Once they put it into the machine and see how it runs, then that sort of gets them thinking, you know, this is not a bad idea. We need this. In fact, that's how it kind of got implemented in our shop as well. You got to get the people away from the plastic and the brass balls to get them into actually looking at something different, more efficient. And the whole purpose of the coolant line being able to be run unattended is so that you have uptime on your machines. The last thing you want your guys out there making the money and all the insurance and everything else is to have the machine down while they're replacing 20 of these little lathe balls in their lathe. Or coming in the next morning and you've got a $2,000 part that was ruined, or $150 worth of tools that were ruined. So we're really trying to help focus our end users to keep into the 720 hours of uptime per month. So that's always the goal that we're trying to get. If they're not getting 720 hours, you know, what can we do to help get towards that goal? And using this, the coolant line is just a small part of what we can do to help them get that run time. So one thing I will caution too, obviously when you're in the field, we have had some issues. You can over torque these a little bit, any more than 2 or 3 foot-pounds, and you can pop one of the fittings through the actual nut. So just to be careful of that, as if you have a nut that comes across, you don't have to really torque them down that hard to get them tight, but we have had that happen in the field, so we just adjust the torque, and then that solves that problem. There's a question about the ball size. Is this ball size standard with all the turrets you see out in the field? And the short answer is no. So that's why we have a 12, 14, 15 millimeter ball sizes, because there's all different sizes. And what?
And 10 millimeters.
And 10 millimeters, sorry, yeah, and 10. We go all the way down to 10. Those are the ones that we've seen the most of, but we do have these available in all those different sizes. I wish I could tell you they were all standardized, but unfortunately in this business, very few things are really standardized. So that's why we have a wide variety in our catalog to hunt and peck. And I'll be honest with you, when you ask the operator, 9 times out of 10, they don't know what size it is either. So they have to take it out and measure it. So.
Well, they also have introduced the new adapter that fits the Mazacs that have the press pin fitting. And basically it's like a collet chuck. And you pop out the Mazac fitting, stick this in, tighten it with a 6 millimeter wrench, and then it has the standard 1/4 inch system thread that we can work from.
Yeah, if those of you didn't hear, Piranha does have one that fits a Mazac system, and it's a press fit, not a screw fit. Like these all have screws in them that lock it in place, and Mazac has like a press fit, almost like a hydraulic fitting type. And so we do have that, a 6 millimeter. We don't have them here yet, but Piranha does have them. So another question was, do we have any information on saving the customer with coolant? We do have a customer, and Dan, you may want to chime in on this one, that they actually did a study of the cost of outfitting their entire shop with coolant and how quick the payback was going to be. How quick was their payback, Dan?
They were talking about 8 weeks.
So we're talking a customer that had quite a few machines. I want to say the investment was going to be in the 6 digits, just buying the coolant line to outfit all the machines, and the payback was going to be about 8 weeks. Whoever was just talking, it was all broken up, so I can't hear. Oh, okay, Toby.
Yeah, that was Swade's lock.
Okay.
Yeah. That,
I've got another question about the Morosiki Dura turns. The diameter is 12.5 millimeter, and that's our standard ball size. That's actually in our 1/4 inch kit. Our standard is 12.5 millimeter. So yeah, we do have the 12.5 millimeter. We do have a new catalog, and this is available. We have some of our reps out here. We'll be glad to get them out in the field so you guys can use the catalog. It's got all 3 of the systems in it. We also, some people have asked about adapters. When it comes to the mills, the threaded adapters that we have, and we do have quite a few different sizes in the catalog. They're the most common. I'm not so sure we've ran into a whole lot of issues with not having the correct adapter, but they all come with the Piranha thread on one side, and then the side that goes into the machine. Anywhere, you got a 1/4 inch, you've got BSPP, BSPT fittings, and then just MPT fittings. And I will tell you, in the field, again, the operators have no clue what their threads are. So when you take these out in the field, you almost have to hunt and peck to figure out which threads are actually going to fit. Once you do that, everything ties off into the Piranha fitting on this end. So usually the biggest struggle is figuring out what we're threading into to get started with. Once that happens, we're good to go. Any other questions out there?
well, then I would say the #1 target is both lathes and screw machines, particularly older screw machines like Acmes, things like that.
So the comment was from one of our local reps who's got a lot of this out in the field. The biggest target that we use right now are lathes and screw machines, particularly the older screw machines, the Acmes, some of the Ankas. Those are really the bigger targets that really, to be honest with you, have coolant issues. The mills, somewhat, it's a little bit harder to get the mill guys in to change out their coolant line, but when you start with the lathes, and sometimes the grinders as well, but with the lathes especially, you can just see the difference that it shows. Once you get it into one, it just sort of snowballs around the shop. So
Yeah, basically on the lathe, like what you're looking at, it averages about $90 to $100 per position when you average it out.
So if you didn't hear, Dan was saying about the average cost for the lathe. Did you say, Dan, was about $90 to get it outfitted?
Yeah, so, but that's averaging it over all the different types of tools, whether it's threading, cutoff, booty, turning, boring, etc. It averages about $90 per station.
So yeah, I'm sorry, yeah, $90 per station. So as you can see, we got quite a few stations here. So to outfit a whole lathe, times that by the average of about $90. Sometimes a customer will balk at it. So that's why it's real important to get it into the machine, show them running, and we just told you about one of the customers where the payback was 8 weeks on a 6-figure investment. So I know eventually, initially they may get shell shocked, especially in relation to a plastic lock line type product. The cost obviously is more expensive, but if you ruin one part, it pays for itself. So we've got another question about what's the norm for the brass ball size, a quarter or a half. Well, this one right here, I haven't, Dan, you can correct me, I have not seen any that were actually an inch. They're all
We don't have, it's not available in the half-inch system, just a quarter and now the 1/8 inch.
Well, I think he wants to know what's the normal ball, the brass ball, what's the normal brass ball size? So my answer is there isn't really a normal size.
14 millimeters and 12 millimeters are the most prevalent, followed by 15.
So 12 and 14 are the most, 15, and then obviously 10. The smaller ones you don't see that often.
Yeah, the 10 millimeter you'll see on VDI heads, live heads, like Benz or WTO.
The VDI heads are common with the small one, the 10 millimeter. But any more to the bigger lathes like this, you're talking, you know, the 12, 14, 15 size millimeters. We have literature on the Mazak one. I don't at this time, but we're in the process of getting that for you. So that will be up as soon as we have it. Any other questions out there? I just can't stress enough it's just an item that our reps do have, the demo kits, to go into your customers and show them and get it on one of their machines, a 30-day trial, so it doesn't go cost them anything to try it, to get it installed, show them how it works. And I don't know, very few people really have turned it back into us. So if you got any other questions, we'll be glad to answer them. These webinars, if you've got a customer that would like to see it in action, let me know. We can come out here and film it again for you. This is also going to be recorded, or is being recorded, and will be up on our YouTube channel so that you can download it and send it to anybody that may have missed it, or you want somebody to see it.